Okay. I need your attention up here, please. For today, we are covering the remainder and factor theorems. Any of the processes we are using today, they are not new. So today we are using processes of synthetic division and factoring, which you've already done, but you'll see kind of in a new way how they can help us solve different types of questions. So this is more of kind of a review day while also letting you know when you do this process, it actually means this as well. So to start out, this isn't technically an example per se. It's more to help you understand how we can use synthetic division to find or evaluate a function, find a function value. When we use synthetic division to find a function value, it's called synthetic substitution. So that's a term you're going to want to understand what it means. It means synthetic division, but you only focus on one part of the synthetic division. So I have here synthetic division can be used to find the value of a function. This is how. So I have considered this polynomial function f of x, and we are going to divide that polynomial by x minus 3 using synthetic division. So this is a review of synthetic division if you've forgotten or didn't understand it to begin with. So with synthetic division, again, you want to make sure the polynomial you have is in standard form, highest power, and then in decreasing order for the powers of x. If you're missing any terms, we aren't here, but if you're missing any, remember that you need to fill in the zeros. So I'm going to list those coefficients, -3, +5, +4. And then in the box, you place your r value from your divisor. So if we're dividing by x minus 3, what is the r value? +3. And then draw the line, bring down your first coefficient. So that first coefficient is always brought down under that line. That's just the setup part. And then reviewing this process, whatever number is now below the line, you multiply that number by your r value. So -3 times 3 is -9, and that gets written below the 5. And then the 5 and the -9 get added together. So 5 plus -9 is -4. That goes below the line. And then you repeat. -4 times 3 is -12. -12 plus 4 is -8. And the last number is always your remainder. Okay, so while we aren't actually needing for this to write out the full quotient with remainder, I do want to just to remind you how to write it out. So if I were to actually write out the quotient with the remainder, the -3, -4 are the coefficients, so I would have -3x to the first power, so 1 power less than what I started with, and then -4, and then for the remainder, it would be -8 or plus -8 over the divisor x minus 3. So this is how the quotient would be written. That's just a reminder for you. So synthetic division, how to set it up, how to work through it. Last number is always your remainder. And then remember to fill in the zeros if needed. Okay, so now what we are going to do, we're going to come back to this, but now we're going to find the function value f of 3. So for the same function that we were given above, we're going to find f of 3. How would we do that? How do we find a function value? Yep, plug 3 in for x and then evaluate. So we would have -3 times 3 squared plus 5 times 3 plus 4. For this. I'm trying to make a connection. We're seeing how we can use synthetic division to find a value of a function. So here we did the synthetic division, and now we're going to find the function value and then compare to see how the synthetic division actually gives us the function value. So the value that we're going to find here is going to be part of what we found up here, and we're going to make that connection. So if I evaluate this, I need to make sure I do this exponent first. So I have negative 3 times 3 squared is 9, plus I'm going to multiply 5 and 3 right away is 15, plus 4. So this is negative 27 plus 15 plus 4. Anybody have what that is already? Negative 8. Thanks. Okay, so here's what I want you to notice. Again, we're leading into how do we use synthetic division to find a function value. Notice, and it says here at the bottom, notice the value of f of 3, which is negative 8, is the same as the remainder, which was also negative 8, the remainder when the polynomial is divided by x minus 3. So whenever you're finding a function value, like in this case, when we divided by x minus 3, the r value is 3. So that means f of 3, that 3 is your r value. And this is what the remainder theorem demonstrates. So I realize this didn't copy the greatest on the sheet that you have, but what the remainder theorem says is that if a polynomial p of x is divided by x minus r, the remainder is a constant p of r. So if you want to find a function value using synthetic division, the remainder is your function value, p of r or f of r, whatever your function was named to begin with. And then what it states below that, that's just breaking it down into how you could actually write that polynomial then in factored form. We're going to talk about that in a later example. But what you need to understand right now, and we're going to go through examples of this, is when you do synthetic division, the remainder is the function value p of r or f of r. And that's going to be useful to us as we move forward. So for right now, I just want you to understand how to do it. So as I've already mentioned, when you apply the remainder theorem using synthetic division to evaluate a function, this is called synthetic substitution. So it could be a more convenient way to find a function value depending on the function you have. If you have this really long function with really high exponents, using the synthetic division process could be more convenient or maybe a little bit easier, or cause you to make less little mistakes versus substituting it in directly. So when we work through example 1, it says it gives us a function f of x, and it says find f of 6. I want us to find f of 6, not by plugging 6 in, but by using synthetic substitution. So I know I didn't include it in the directions, I didn't type it in, but thinking ahead, well, it says it on the assignment, thinking ahead to the homework quiz tomorrow, to your Chapter 5 test next week, Friday, if I say in directions, find a function value using synthetic substitution, I'm actually looking at how you found the value. I'm looking to see, do you know what that process actually means? And synthetic substitution just means you're using synthetic division, and the answer is your remainder. So if I am using synthetic substitution, I need to set up my synthetic division. So I'm going to list out the coefficients. I do need to make sure in this polynomial, since my highest power is 4, I am missing an x cubed term. So I need to make sure I fill in a 0 for x cubed. I do have an x squared, an x, and a constant, so that's the only one that I'm missing. So my coefficients are 2, 0, negative 5, 8, and negative 7. And then here's where you need to be clear on r, when to change the sign, when not to change the sign. So I'm going to move this back in a minute here. I'm just moving it up to show you something. When I say to divide by, say, x minus 3, and you're finding the r value from that, you change the sign for r. But if I'm asking you just to find a function value, the value that I'm giving you is the r value. So when I say find f of 6, The 6 is the r value. Don't change it to be negative 6. This means we're really dividing by x minus 6, but the r value is positive 6. So 6 does go in that box. And then I can bring down the first coefficient and go through the synthetic division process. So multiply 2 by 6, and that's 12. Add it to 0, that's still 12. And then I need 12 times 6, 72, plus negative 5, 67. And then 67 times 6 is 402. Add 8 to that, and that's 410. And then multiply 410 by 6, and that's 2,460. And add negative 7 to that, 2,453, and that would be the remainder. But with synthetic substitution, the remainder is equal to f of 6, to the function value at 6. So my answer, f of 6, is 2,453. Okay, now what's nice is if I'm asking you to use this process and you do it and you're wondering, is this correct? You could check your answer by then just plugging 6 into the function and see that you get the same thing. If you don't, then you'd have to kind of check both methods that I do the math correctly both ways. But you could use that as a check. But if I say use synthetic substitution, this is the work that I'm looking for, and then I'm looking to see, do you understand that the remainder is the answer? Okay, any questions on that one? Okay, so then for example 2 on the top of the back side, this is an application of that. So we have the number of college students from the United States who study abroad can be modeled by the function, and it gives us a function s of x. I'm just going to highlight that function because that'll be used. And then it says x is the number of years since 1993, and s of x is the number of students in thousands. So I'm going to highlight that as well. It's important when you are given a function, you understand the units on the variables. So x is number of years since 1993. S of x, which is like the y value, is the number of students in thousands. And then it says how many U.S. college students will study abroad in 2018. So I'm going to have you work through this in your groups. However, if the year is 2018 and x represents the years, what x value would be used? 25. Okay, so number of years since 1993, 2018 minus 1993 would be 25. Okay, so I want you to use the 25, use the function, practice using the synthetic substitution process we just did to answer that question. How many college students would study abroad in 2018? And then in a minute here, I'll walk around, make sure we can all get the correct answer. Yeah.
So you could write that like 286,440,000 students, or you can multiply this by 1,000.
Okay. Double check what you have. I know some of you were still working as I was walking around. And then one other thing I didn't, rather than saying it to maybe each group individually, I just thought I'd say it to the class. Some of you did this already. So your remainder would be the answer. It's looking for that function value evaluated at 25. Now, the y values are representing the number of students in thousands. So if you write your answer, you need to make sure as a label, you're not saying it's 2286.04 students, it's 2286.04 thousand students. So if you just wanted the number of students, you would multiply that decimal by 1,000. It's really representing 2,286,040 students. So either way you write your answer is fine. You just have to be careful of your label. Don't just say this is the number of students. It would be this many thousand students. That would be the only thing to double check or be careful of with your label on your answer. But if you got the right value, then you're doing the process correctly. Any further questions on that before we move on to the last example? Okay. And I know this next part, based again on how it copied, it's super light on your sheet, so I apologize for that. But the next part is now using synthetic substitution to determine if a binomial is a factor of a polynomial. So we can also use synthetic substitution to help us factor. So think to the last 2 days when we spent time factoring, solving by factoring. The synthetic division can also help us factor. So it does give an example here. This is looking through this is making sure you understand how this is all pieced together. So the synthetic division that is shown here shows the quotient of, and it gives this polynomial 2x cubed minus 3x squared minus 17x plus 30. So you can see those coefficients here. And x plus 3, they're dividing by x plus 3, so the r value is negative 3. And then it shows the work for that, and it shows what the quotient is. So you see the coefficients of the quotient, the remainder is 0. And so the quotient is just the 2x squared minus 9x plus 10. So this next part, it says, when you divide a polynomial by one of its binomial factors, the quotient is called a depressed polynomial. So while I haven't called it that up to this point, this is what you've been doing already. A depressed polynomial has a degree that is 1 less than the original polynomial. So if your original is x cubed, your quotient starts with x squared, is what that means. And it says, from the results of the division and by using the remainder theorem, we make the following statement. So it shows here, now it's taking the original polynomial and writing it in factored form. So this is the original, and then this would be considered the factored form. Plus, and this is the factored form plus the remainder is just 0. So that's not even needed to add on to it. Okay, so the two factors are the x plus 3 that it was divided by, and then the 2x squared minus 9x plus 10 that was the quotient. So the remainder being 0 is the important thing here. Since the remainder is 0, that means the function value evaluated at -3 is 0. And that means that x plus 3 is a factor of the original polynomial. And I think I talked about that when we first started dividing. So this is all the way back to 5.2, the second day of this chapter. I said that factoring is a way to divide polynomials. And I think we did an example of long division, and then I showed you when you factor it that you would still get the same quotient, but it would be in factored form. That's what happens when you get a remainder of 0. If your remainder is 0, that means you can factor the polynomial. It's a factor. So this factor theorem is very important for you to understand. And all it says is that the binomial x minus r is called a factor of the polynomial p of x if and only if p of r is 0. This means the remainder is 0. So when you divide p of x by x minus r, if you get a remainder of 0, then x minus r is a factor. And that can help you factor a polynomial, which then helps you solve polynomial equations. So that's kind of how it's all building or where it's going to lead. So that's what we're going to be doing in example 3. Example 3, this type of question has two parts to it. The first part, it says determine whether x minus 3 is a factor, and then find the remaining factors of the polynomial. So your answer is going to be the fully factored form of the original polynomial. So looking at the first part, to determine whether x minus 3 is a factor, we want to divide the polynomial by x minus 3. If the remainder is 0, it's a factor. So I'm going to use synthetic division and set that up. So looking at the polynomial, I don't need to fill in any zeros. So I have coefficients of 1, 4, -15, -18. And if I'm dividing by x minus 3, what's the r value? 3. So I want 3, positive 3 in the box. Bring down the first coefficient of 1. And then go through the synthetic division process. So 1 times 3 is 3, plus 4 is 7. 7 times 3 is 21, plus -15 is 6. 6 times 3 is 18. Plus -18 is 0, and that's the remainder. So this means, if it says determine whether x minus 3 is a factor, this means that it is, because the remainder is 0. So I'm just going to write that down if you want to include it, just so when you look back at this, you understand. The remainder equals 0, so x minus 3 is a factor. So what that means, or how that helps us to then find the remaining factors, is I'm now going to write my original polynomial in factored form. So I know that one of my factors is what I divided by, the x minus 3. The other factor right now is what I got as a quotient. So the other factor is going to be x squared. Since I started with x cubed, and now I have 1x squared plus 7x plus 6. Okay, and then either this is going to be your answer, or you have to make sure whatever your quotient was, in this case the x squared plus 7x plus 6, if you can factor that even further, you should. But if you can't factor it further, then this would be your answer. The remaining factor would just be your quotient. So I'm going to ignore the x minus 3. My quotient is a trinomial. So to see if I can factor it, I can set up a diamond. And for that trinomial, what would we be multiplying to? 6 and adding to 7. Are there two numbers that work? 1 and 6. So then, because I have a 1 in front of the x squared, I can go straight to factoring this. My two factors then would be x plus 1 times x plus 6. And then I still have the factor of x minus 3. So this is the fully factored form of the polynomial. X minus 3 was the factor we were given, and then x plus 1, x plus 6 are the remaining factors. And again, where this is leading, how this is helping us, is if I gave you this equation, if I said this polynomial is equal to 0, solve it, it is now factored. And if I set each of these equal to 0, I would get my 3 answers. So that's where this is leading. Factoring is leading to help you solve equations. Okay?